Given the polynomial f of x equals 3x to the fifth plus 5x to the fourth minus 4x cubed plus 7x plus 3, find the quotient and the remainder of f of x divided by parenthesis x plus 2. Okay, here's what we know. We know that if we synthetically divide f of x by x minus c, it would look like this. You put the f of x coefficients under the division symbol and you divide by c, and the stuff on the bottom, it's called the quotient, plus the number at the end is our remainder. Okay, so we're going to use this in order to answer the question about the quotient and remainder. So we have this polynomial 3x to the fifth plus 5x to the fourth minus 4x cubed plus 7x plus 3 divided by x plus 2. Okay, so put the negative 2. Now why are we putting negative 2 out in front? Because we, according to the cloud, we have to be dividing by x minus a c, and it's a c number that goes out in front of the synthetic division. So what number are we subtracting from x in the bottom of this fraction that we've written? Negative 2. So negative 2 goes out in the front, and then we list the coefficients of the polynomial f of x in descending order, plugging in 0 whenever we're missing any power of x. And indeed, we are missing x to the second power, so be careful here. There's the 3 for the first coefficient, okay, a 3, and then we have a 5, and then a negative 4, and then a missing power, so there's a 0, then the 7, and the 3. Okay, so you understand we put the 0 in there because x to the 0 power is missing, so it's being multiplied by 0. That's why we can't see it. Bring down the first number, and we're going to multiply by negative 2. We'll get negative 6, and we're going to add 5 plus a negative 6 gives us a negative 1. Multiply by negative 2, add, we get negative 2, multiply, add, we get 4, we get negative 1, and finally we get our remainder 5. So here is our quotient. All these numbers that came before the last number, that's our quotient, and our remainder is the 5. Thus, the quotient is, okay, now I'm going to take those coefficients on the bottom, and I'm going to write them as a polynomial 1 degree lower than f of x. F of x was a 5th degree polynomial. Look at the very top. F of x was a 5th degree polynomial, so those quotients, those values are going to be coefficients for a 4th degree polynomial. So this will give us quotient is 3 times x to the 4th minus 1 times x to the 3rd minus 2 times x to the 2nd plus 4 times x, and then the minus 1 for the constant. And the remainder, of course, is the number at the end. It is a positive 5. Now a comment, when the remainder is equal to 0, that's when we have a party, because when that happens, we know the top polynomial is divisible by the bottom polynomial. In other words, the second polynomial in a factor is a factor of the first polynomial when they give it to you that way. The first polynomial will be a factor of the larger second polynomial.